Oh, Math Gad, guys. Welcome to today's video in which we're going to be talking about what are terminating decimals, the basic concepts, and how you can express those as fractions. Before we begin the video, guys, it's very important that you leave a like, a comment, and subscribe to the channel. Remember to click on that notification bell. That way you're notified every time OHMATHGAD uploads a video. So let's begin.
Oh my God.
Welcome back, guys. So today's video is about understanding what is a terminating decimal. Let's begin. So the first thing we're going to do today, guys, is for a change, we're going to start with a problem. And as we breeze through the problem, we're going to see a concept that maybe you guys have heard of before, which is the concept of terminating decimals. King Ferdinand was a very rich king, and he had many pastry chefs at his disposal, so he had lots of cake to spare. One day he decided to give his collection of 3,550 golden cakes to the 20 wisest men in the village. How many cakes did each man receive? Okay, so again, we have King Ferdinand, right, who wanted to give 3,550 cakes, and he's going to divide that and he's going to give that to 20 men, the 20 wisest men in the village. And now we're posed with the question of how many cakes did each man receive? Okay, so again, in order to know how many cakes each man received, we have to make the division of the total amount of cakes divided by the total amount of men that are going to receive the cakes. First thing we have to do is divide the total amount by the 20 men that are going to receive it. So 35 divided by 20, that's 1. 1 by 20 is 20. You subtract, and that's 15. You take the 5 down to 155 divided by 20. That's 7. 7 times 20 is 140, which is going to give us a remainder of 15. Then it's 150 divided by 20. It's again 7. 140. We get 10. And now, because we haven't finished, we can add a decimal point or decimal comma, right? And it lets us add a 0. So then we divide 100 divided by 20. That's 5. 5 times 20 is 100. And our remainder here is 0. Now, guys, this is going to be the key to our problem. So the fact that there is a remainder of 0 actually is going to let us know that it's going to be a terminating decimal. So this right here, guys, is a terminating decimal. Why? Because we know that each man received 177.5 golden cakes, right? So in this case, guys, because the remainder is 0, this number actually stops. And because that number is finite, it stops, we know that is a terminating decimal. Right? So we have to take that into account. Whenever we divide two numbers and that number or that fraction give us a remainder of 0, that number or that decimal is going to be terminating. So what is a terminating decimal? A terminating decimal, first of all, is a decimal that has digits that end. For example, a number like 67.9 finishes in 9. A number like 4 divided by 2 is 2. That number finishes. So those are terminating decimals. But another number that doesn't finish, for example, is a number like 0,3333, and we add a line whenever that 3 continues. So that means that 3 is not finite, but is infinite, right? And that is not a terminating decimal. But that is not today's lesson. Today's lesson is when we have a finite amount of numbers, and that is a terminating or finite decimal. So the second definition is that a terminating decimal is a rational number that has finite number of digits after the decimal comma. The fact that it is a rational number is pretty helpful because a number like 2,5 or 2.5 finishes and ends because of the 5. How can we express a number like 2.5 as a fraction? Well, because it is a rational number, we know that it can be expressed as a fraction of two numbers, of two whole numbers. So 5 divided by 2, right? That is another tricky thing that people usually forget. So take that into account, guys. A rational number that has a finite number of digits after the decimal comma. It doesn't matter if it's 3 digits, it doesn't matter if it's 2 digits, or if it's 10. If the remainder at the end is 0, that's all that matters. Take a look at some examples. So example A is 57.1332. So again, this number right here has a finite number of digits after the decimal comma. So it has 1, 2, 3. It has 4 digits after the decimal comma. So that means that this is a terminating decimal. You have to remember that, guys. The number finishes, it has no ... or it doesn't have a line here. That means that it is a terminating decimal. Number B is 0.49. So in this case, guys, it doesn't matter if the number starts with 0, something or 0 point something. It doesn't matter. The number still finishes. We have 2 digits after the decimal comma, right? So again, it is a terminating decimal. So number C is 0.75. Again, we have 2 digits after the decimal comma. Because we have 2 digits after the decimal comma, it is a terminating number. So guys, to recap, the first number is a terminating decimal because it has 4 digits after the decimal comma, and they are finite because they don't continue. And in number 2 and 3, so examples B and C, we have 2 digits after the decimal comma. That means that they stop there. The number doesn't continue. Because the number does not continue and it has a finite number of digits after the decimal comma, it is a terminating decimal. Okay guys, so the next video is going to be about non-terminating decimals or repeating decimals. So you're going to be able to tell the difference between these and those when you watch that video. But for now, feel free to rewatch the video if you didn't understand some concepts, and I'll see you on the next one. Bye everyone!
Check out these other videos to improve your math skills, and make sure you click that subscribe button to make the community grow. Follow OHMATHGAD in its social media accounts, drop a like, a comment below, and see you on the next one. Bye!